Hello everyone. In this problem we are asked to graph the solution of x of t convolute with x prime of t. And we are given the following x of t graph. So to start out, let's graph the x prime of t, which is the first derivative of x of t. So referring to our x of t block, we're going to start from the negative end of t going into the positive direction. So when we approach negative 1, we can see that we increased our height by 1 unit. So we're going to have a direct delta function at t equals negative 1 with a height of 1. And as we're continuing to follow along to the positive direction of t, our height of 1 remains constant. Therefore, our first derivative is going to be 0. And as we approach t equals 1, we're actually going to decrease by a unit of 1. So we're going to have a direct delta of negative 1 when t is equal to 1. So from here, we can actually jump straight into our final graph of x prime, with the final graph actually equaling this. So x of t convoluted with x prime of t, negative 2, 2, negative 1, and 1. Now, how do we simply jump to the end? Well, I'm going to show you two ways on how we can actually solve for this. The first way is knowing that any function of t convoluted with a direct delta of t is going to equal itself. And any function of t convoluted with a direct delta with a time delay is going to equal itself with the time delay. So from this function right here, we can see that we have two direct delta functions right here. So we can take our first one at minus 1, which is right here. This can actually be our center focal point as if we were at the origin right here. And we are simply multiplying our x of t with our direct delta of 1, which gives us our first half of the function of the left side of the origin. And then we can look right here, we can see our negative 1 direct delta. So negative 1 times our x of t function gives us the same function at negative 1, or sorry, at t equals 1 in the negative direction. Now, what if we wanted to use a Laplace method? So we can actually rewrite our x of t into the following. X of t is equal to u t plus 1 minus u of t minus 1. And then our x of prime would then be equal to the step function, because direct delta is the derivative of a u of t. So we're going to keep the same time delay of t plus 1 minus direct delta of t minus 1. Now, because we have the convolution of x of t convoluted with x prime, we are going to take the Laplace transform, and so we're going to have prime multiplied to x of s. My mistake. X of s prime and x of s. So we are actually going to rewrite these equations with x of s equal to e s, because our 1 right here for the delay is multiplied and we have a positive, and then we're going to put an s underneath for our step, minus e minus s, so we have a minus 1 here over s, and then our x prime of s for the Laplace transform. Since dirac delta, the Laplace transformation of that is equal to 1, we're just going to write e of s minus e of minus s. So, following equation of x of s multiplied with x prime of s is going to be equal to e of s over s minus e minus s over s. Multiply it to e of s minus e minus s. So, doing our factoring, we get e of 2s over s minus 2 over s plus e minus 2s over s. And now we're going to take the inverse Laplace transform of that and get with our time delay. So we get a u function with the time delay of t plus 2 minus 2 times our step function plus a step function t with a time delay of minus 2. And so graphing the function here in terms of time, we're going to start at t plus 2, which is going to be when t is equal to minus 2. We're going to go up one step, continue along until we get to t equals 0, or we're going to minus 2 units. So 1, 2, we are at negative 1, and then we're going to go to the right until t equals 2, where we're going to add 1 unit. And then it's going to continue along, and voila! That is our final function output using the Laplace transformation, and it's the same exact graph that we had using our little cheat method with the multiplying with the dirac delta functions. Thank you for watching, and see you next time.